Good morning, everyone. Our topic for today is Topic 1, Lesson 1 Patterns with Exponents and Powers of 10. So, you will find this lesson on page 5 to 8 from your book. Here are the learning objectives for today's lesson. You're going to explain patterns in the number of zeros of the product when multiplying a number by powers of 10. Evaluate the value of exponents in real-life situations, and use patterns and the properties of multiplication to calculate a product when multiplying by a product of 10. Use whole number exponents to write powers of 10. Let's have a review. Powers and exponents vocabulary. So when we say factors, it means these are the numbers that are multiplied together. Like for example, we have 2 multiplied by 2. So 2 and 2 are what we call the factors. Base. Base means the number being used as a factor. So like for example, I have 10 to the second power. So 10 is what we call the base. So this base is a number being used as a factor because the equivalent of 10 squared means 10 multiplied by 10. And 10 are what we call the factors. Exponent. When we say exponent, it means tell us how many times a number is used as a factor. Like for example, we have 10 squared, so 2 is an exponent, so it tells how many times. It should be 2 times a number is used as a factor. So that is what we call an exponent. Power. Power is a number that is expressed using exponents. Squared. Squared is a number that has exponent of 2. Like for example, I have 4 squared, 3 squared, 6 squared. So this is 4 squared, 3 squared, and 6 squared because a number that has an exponent of 2. Or to the second power, 3 to the second power, and 6 to the second power. Cube. Cube is a number that has an exponent of 3. Like for example, I have 3 to the third power, or we can say as 3 cubed. 12 to the third power, or we can say that 12 cubed. 6 to the third power, or we can say that as 6 cubed. So those are the powers and exponents vocabulary. Now, exponent form, as you can see, this is the base and this is what we call the exponent. Factor form. So 2 cubed is equivalent to 2 times 2 times 2. It's not possible that we're going to multiply the base multiply the exponent. 2 cubed means we're going to multiply the base. How many times? It depends upon to the exponent. So your exponent is 3, so you're going to multiply the base 3 times. So 2 times 2 times 2. And 2 times 2 times 2 are what we call the factors. So what is the equivalent of 2 cubed? 2 cubed is equivalent to 8. Why? Because 2 times 2 is 4, then 4 multiplied by 2, that is equivalent to 8. So 8 is what we call the standard form. 2 times 2 times 2 is what we call the factor form. And 2 cubed is what we call the exponential form. Now let's answer this one. 4 cubed. What is the factor form of 4 cubed? It should be 4 times 4 times 4. And what is the standard form? The answer is 64. Why? Because 4 times 4, that is 16, and 16 multiplied by 4, that is equivalent to 64. What if the given is factor form, and you're going to find out the exponent form? So 7 times 7, what is the exponential form? So what is the base? The base is 7, and how many times you repeated 7? It should be 2 times. That's why the exponent form is 7 squared. And 7 squared is 7 times 7, and 7 times 7 is equivalent to 49, and that is what we call the standard form. Next, 2 to the fifth power. So 2 to the fifth power, it means we're going to multiply 2 5 times. So 2 times 2 times 2 times 2 times 2. So 2 times 2 is 4. 4 times 2 is equivalent to 8. 8 times 2 is 16. And 16 times 2 is equivalent to 32. So those are the exponential form, the factor form, and the standard form. Now, always remember this. When the exponent is 0, and the base is any number but 0, the answer is 1. Like for example, 2 to the 0 power, it means the answer is equivalent to 1. 4,638 to the 0 power is equivalent to 1. In short, any number, if the exponent is 0, that is equivalent to 1. Any number except the number 0. 0 to the 0 power is equivalent to undefined. So always remember that one. How to read powers and exponents? Normally, say base number to the exponent number expressed as an ordinal number power. So when we say ordinal numbers, it means this is the first, second, third, fourth, fifth, and so on. Like for example, we have 2 to the fifth power. So we will say this as 2 to the fifth power. 10 to the first, 10 to the second, or 10 squared. 10 to the third, or 10 cubed. 10 to the fourth, 10 to the fifth power, 10 to the sixth, and so on. Let's analyze this problem. A store sells AA batteries. There are 10 batteries in a package. How many batteries are in 10 packages? How about for 100 packages? Solve these problems any way you choose. You can use appropriate tools. Place value blocks can be used to help solve problems. Let's analyze this student's work. For Victor's work, Victor finds the values using the place value blocks. As you can see, he said that 100 batteries in 10 packages and 1000 batteries in 100 packages. For Gabriel's work, Gabriel writes equation to find the product. So 10 multiplied by 10 is 100. 10 multiplied by 100 is equivalent to 1000. So 100 batteries in 10 packages and 1000 batteries in 100 packages. Now, how many tens are in 100 and how many tens are in 1000? Write equations to show your work. As you can see here, 10 multiplied by 10 is equivalent to 100, and 10 multiplied by 100 is equivalent to 1000. So the answer is 10 and 100. How can you explain patterns in the number of zeros in a product? Let's analyze this problem. Tamara's new horse weighs about 1,000 pounds. How can you show 1,000 as a power of 10 using an exponent? So the exponent is the number that tells how many times a base number is used as a factor. So we're going to answer that question. We're going to write 1,000 as the product using a 10 as a factor. So 1,000, the factors are 10 multiplied by 10 multiplied by 10. Because 10 multiplied by 10 multiplied by 10 is equivalent to 1,000, or if we're going to write using the exponential form, the base is 10 and the exponent is 3 because you multiply 10 3 times. That's why 10 cubed is equivalent to 10 multiplied by 10 multiplied by 10, and that is equivalent to 1,000. So the exponent 3 shows that the base number 10 is multiplied 3 times. So 1000 is written as 10 cubed using exponent. So Tamara estimates that her horse will eat about 5,000 pounds of hay each year. So how can you write 5,000 using exponents? So using the pattern, if that is 5 multiplied by 10 to the first power, it means 5 multiplied by 10 is equivalent to 50. If it is 5 by 10 to the second power, means 5 multiplied by 10 multiplied by 10 is equivalent to 500. Why 10 multiplied by 10? Because 10 squared means 10 by 10. 5 multiplied by 10 cubed, it means 5 multiplied by 10 by 10 and by 10. So why I multiplied 10 3 times? Because the exponent is 3. As you can see, if you observe the exponent and the number of the number of zeros in the product is the same as the exponent. So 10 to the first power, it means that is 10, and 10 has one zero. That's why we need to put one zero there. 5 multiplied by 10 squared is equivalent to 5 multiplied by 10 multiplied by 10. So the exponent is 2, so we need to add 2 zeros. The same thing with 5 multiplied by 10 cubed. So we have 3 as an exponent, so we need to add 3 zeros. So 5,000 is written as 5 multiplied by 10 cubed using exponents. What pattern do you notice in the number of zeros in the products in box C above? So the number of zeros in the products is the same as the exponent. The number of zeros in the products is the same as the exponents. Why are there 3 zeros in the product of 6 multiplied by 10 cubed? Because if we multiply this one, so 6 times 1 is 6, then the exponent is 3, so we need to add 3 zeros, so that is equivalent to 6,000. So why are there 3 zeros? Because the exponent on the power of 10 is 3, so there are 3 zeros in the product. Because the number of exponent is equivalent to the number of zeros. Next, Susan said that 10 to the fifth power is 50. What mistake did Susan make, and what is the correct answer? So 10 to the fifth power, if we're going to change this, it should be 10 multiplied by 10 multiplied by 10 multiplied by 10 multiplied by 10. So we're going to multiply 10 5 times, or we just simply write 1, then the exponent is 5, so we need to add 5 zeros. So the answer must be 100,000 and not 50. So she multiplied 10 by 5 rather than multiplying 10 5 times. Okay, that's why she got 50. But the correct answer is equivalent to 100,000. Now, let's complete the pattern. 10 to the first power means 10 multiplied by 1, and that is equivalent to 10. 10 squared means 10 multiplied by 10, that is equivalent to 100. 10 cubed means 10 multiplied by 10 multiplied by 10, and that is equivalent to 1000. And 10 to the fourth power, it means 10 multiplied by 10 multiplied by 10 multiplied by 10, and that is equivalent to 10,000. If you will observe the exponent, we have 1, and the number of 0, we have also 1. The exponent here is 2, we add 2 zeros. The exponent is 3, we add 3 zeros. And the exponent is 4, we add 4 zeros. That's why the number of exponent is equivalent to the number of zeros. But this is only applicable for the base 10. Okay, if the base is 10. Next, 7 by 10 to the first power, the exponent of 1. So we just simply add 1 zero. Okay, 7 to the 10, 7 multiplied by 10 to the second power, or 10 squared, that is equivalent to 700. 7 multiplied by 10 cubed is 7,000. 7 multiplied by 10 to the fourth power, that is equivalent to 70,000. Now, find each product and use patterns to help. 3 multiplied by 10 to the first power, 30. 3 multiplied by 10 to the second power, 300. 3 multiplied by 10 to the third power, 3000. 3 multiplied by 10 to the fourth power, 30,000. 2 multiplied by 10 is equivalent to 20. 2 multiplied by 100, that is equivalent to 200. 2 multiplied by 1000 is 2000. 2 multiplied by 10,000 is 20,000. 9 multiplied by 10 to the first power, 90. 9 multiplied by 10 squared, 900. 9 multiplied by 10 cubed is 9,000. 9 multiplied by 10 to the fourth power is 90,000. 8 multiplied by 10 to the fourth power, that is 80,000 because the exponent is 4, so you just simply add 4 zeros. 4 multiplied by 1,000, that is equivalent to 4,000. 5 multiplied by 10 squared, that is 500. 6 multiplied by 10,000 is 60,000. 4 multiplied by 10 to the first power is 40. 100 multiplied by 9 is 900. 10 cubed multiplied by 6, that is equivalent to 6,000 because the exponent is 3, so you just simply add 3 zeros. 8 multiplied by 10 to the fifth power, that is equivalent to 800,000. Next question. Write 10 multiplied by 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 10 with an exponent, and explain how you decided what exponent to write. So the answer is 10 to the 6th power. Why? Since 10 is multiplied 6 times, so the exponent must be 6. Number 17. One box of printer paper has 3 multiplied by 10 squared sheets of paper. Another box has 10 cubed sheets of paper. What is the total number of sheets in both boxes? So the answer is 1,300. Why? Because 3 multiplied by 10 squared means 300. Because 10 squared means 100. 100 multiplied by 3 is 300. And 10 cubed is equivalent to 1,000. If we're going to add 1,000 and 300, so the final answer is equivalent to 1,300. Next question. A post is put every 6 feet along a fence around a rectangular field that is 42 feet long and 36 feet wide. So this is 42 feet long and 36 feet wide. How many posts are needed? So since we are talking about around the fence, so it means we need to find out the perimeter. So perimeter, it means we just simply add all the sides. If this is 42, this must be 42. If this is 36, this must be 36. So if we're going to add all of this, 42 plus 42 plus 36 plus 36, so the answer is 6, 12, 14, 16, regroup 1, 4, 8, 9, 10, 12, 15, 156. So the perimeter is 156, and we're going to divide this into 6 because a post is put every 6 feet along a fence around a rectangular field. So 15 divided 6 is 2, 6 times 2 is 12, 15 minus 12 is 3, bring down 6, so 36 divided 6 is 6, and 6 times 6 is 36, 36 minus 36 is 0. That's why the final answer is equivalent to 26. So, how many posts are needed? We need 26 posts. Next, a company had 9 multiplied by 10 to the 6th power dollars in sales last year. Explain how to find the product 9 multiplied by 10 to the 6th power. As you can see, the exponent is 6, so we just simply add 6 zeros to 9. So write 9 and then write 6 zeros after it. Okay? Next, number 20. An aquarium has the same shape as the solid figure shown below. What is the name of this solid figure? That is what we call a rectangular prism. 21. Isaac takes 5 minutes to ride his bike down the hill to school and 10 minutes to ride up the hill from school. He attends school Monday through Friday. How many minutes does he spend biking to and from school in 2 weeks? Write an equation to model your work. So as you can see, 2 weeks is equivalent to 14 days, but he attends only Monday to Friday. So Monday to Friday, that is 5 days for 1 week, then another 5 days for 1 week. So the total is equivalent to 10 days for 2 weeks. So each day, he takes 5 minutes to ride down the hill to school and 10 minutes to ride up the hill from school. So what are we going to do is we just simply multiply 5 multiplied by 10. This is referring to 5 minutes to ride his bike down the hill. Then multiply by 10 days. That is equivalent to 50. And 10 minutes multiplied by 10 days, that is equivalent to 100. So, 50 plus 100 is equivalent to 150 minutes. So, this is the total number of minutes he spent biking to and from school in 2 weeks. Number 22. Santiago hopes to buy a 4-horse trailer for about $12,000. Describe all the numbers that when rounded to the nearest are 12,000. So, what are the numbers that when we round to the nearest hundred, that is equivalent to 12,000? So these are the numbers greater than or equal to 11,950 and less than 12,050. Choose all the equations that are true. So the answers are the second one and the third one. And for the last question, choose all the equations that are true. The answers are the first one and the third one. Always remember, the number of exponent is equivalent to the number of zeros. That's why those are the answers. So that's it. Thank you so much and have a nice day.